Adam,
Alan, Ralph, Jonathan, and Eunice. My grandmother used to tell me stories about the old days. A time of peace, all of them lived together in harmony. But that all changed when intermolecular force projects started. All of the 4 intermolecular benders to complete the intermolecular project. Jonathan, Eunice, intermolecular benders.
What's up guys? Today we will be talking about the intermolecular forces. At first, we all know that there are forces between the molecules and the atoms, and we have these 2 kinds of forces between them. This is the intermolecular forces and the intramolecular forces. Now, we will be talking about the intermolecular forces. Intermolecular forces of attraction is a force between 2 molecules or atoms, and this is also the thing that's responsible for the melting point and the boiling point of different substances. As illustration, imagine having potassium chloride and another potassium chloride and another potassium and many other potassium chloride. And we all know that potassium chloride is an ionic compound, which means it has positive and negative side. And according to Charles Agustin de Coulomb, the one who discovered the electrostatic forces, he stated that the opposite charges will attract each other and the same charge will repel each other. And if we let the potassium chloride molecules, this will attract each other and it will form of what we call the ion-ion forces, which is one type of the intermolecular forces and also the strongest among all. The other types of intermolecular forces are, note that this was arranged from the strongest to the weakest forces. The second to the ion-ion is what we call the ion-dipole force. It appears to the interaction of polar and ionic compounds. The third one was hydrogen bonding. It is a special force of our next force, which is the dipole-dipole force. This occurs between polar molecules. Next is the dipole-induced dipole. It happens in the polar molecules and the non-polar or neutral molecules, that they have only a temporary dipole moment, or which we call the induced dipole. The last and the weakest among all is the London dispersed force. This occurs in non-polar or neutral molecules, but this can be also seen in all forces or in all molecules. And this was known for what we call the instantaneous dipole or the momentary dipole. It means it does not take long or hindi siya tatagal kagaya ng jowa. For you to appreciate more about this topic, let's do some experiment, and here are the intermolecular benders.
The first experiment is what you call bubble dome or B raised to the 4th. First, we need sugar, water, dishwashing liquid, straw, and a bowl. We will mix it all into the bowl. 2 spoons of sugar, and put some dishwashing liquid. Then mix it well. Then get the straw and create a bubble. After that, blow another bubble inside. Then create another and another. I'm sure you're curious while this thing happens and what magic is happening in the bubbles. It is because of the strong interaction of water molecules and dishwashing liquid, and adding sugar to it will make the bubbles stay more longer. In this, we observe that the soluted sugar in water makes it have more attraction to each other, and with the help of dishwashing liquid, the attraction between water molecules lessen. because they become more attracted to dishwashing liquids. And so, the bubbles are formed because of more attraction to water and detergent. And the spear shape of it shows that water is no more attracted to each other. And this shows ion-dipole interaction because water is a polar and the detergent is an ionic compound.
Good day, everyone. So today in our experiment, I'll be with my cousin, Joy, which is her nickname. We'll be playing a game called Water Coin G. I'll only need a glass of water, a bunch of coins, and that's about it. What we're going to do is just put coins in the glass alternatively, and the one that can make it overflow will lose, and the winner will take all the coins in the glass, that's really the premise of the game. And let's begin! So the winner was my cousin, Joy. So, I already gave her the prize, but she had to leave because she had to buy a dress for a coming event. So I can't really invite her on the camera, and she's also shy. So what do you think the force behind the water? What do you think the force is behind that? It is the hydrogen bonding forces between the water molecules. This force makes the water molecules hold strong until they cannot counter gravity and overflow the glass. And this phenomenon is called surface tension, a property of liquid to resist an internal force, and that is water coin G. Good day, everyone.
Hi. The second experiment is titled Liquid Hates Each Other. The materials that we need are water, glitter, salt, acetone, food dye, and an empty container. First, we have to dissolve the color from the glitters using the acetone. After that, we'll put food dye and water together. Now, we'll mix these two solutions in this empty container. And look, the solutions combined. But here's the twist. We're going to add salt into the solution to separate the water solution and the acetone solution. Shake the solution to dissolve the salt. Now we wait.
One eternity later.
After a few minutes, this is what we have. The reason behind this is called the ion-dipole forces. As we all know, salt dissolves in water because both of them are attracted with each other. And that is why the red water solution sunk at the bottom, leaving the blue acetone solution above. And that is ion-dipole force.
So, after all the experiments we have seen, not only intermolecular forces but some, makita tayo ng hydrogen bonding force na kung saan pinapakita kung ganito kalakas na kaya niyang i-hold yung water molecules against the gravity ng Earth. And also we have seen an ion-dipole force between detergent and water molecules in the bubble dome experiment, wherein in this kind of structures is very strong so that it will be able to form a bubble. And the last experiment was also an ion-dipole force, but this time it shows also an ion-dipole force compared to the others. The attraction between water and salt was indeed strong because even the mixture is shaped very well, the molecules of water and salt must be able to attract to each other and to be on the one side of the container. There are more experiments to come that shows intermolecular forces, so watch out. Again, this is our
Intermolecular benders.